Hello, I'm Rasmus Benestad from the Norwegian Meteorological Institute, and I'm presenting a CORDEX Flagship pilot study project led by Bernardino Nantumbo from the Mozambique National Meteorological Institute, and also other colleagues from Mozambique and Rwanda and South Africa. So this project started about a year ago, but we were hit by the COVID pandemic, so we have been a little bit inhibited by that. The idea was that we would have some physical workshops which have been postponed. But nevertheless, in the first year, we tried to start with some capacity building to, for instance, build up an inventory of local data which we could share among ourselves for this work. And also we've held some Zoom-based art training sessions, 3 sessions so far with somewhere between 40 and 50 participants. Well, we have been training colleagues in elementary use of R and introduction to R, but also R-based climate analysis and empirical statistical downscaling in using this ESD tool that we have developed, which is R-based as well. And then next we will start to compare the ERA 5 reanalysis or ERA 5 land reanalysis with the local data. And the interesting question is whether we can use the empirical statistical downscaling and ERA 5 to fill in missing data gaps. So we'll test that. Here's some examples of the problem. You see it on the left hand side. These are GCM results from Eastern Africa and Southern Africa, and the x-axis here shows the change in temperature, and the y-axis shows the rainfall in millimeters per day. And you can see that the orange markers represent the CMIP 5 and the blue markers represent the CMIP 6 runs. You can see that the CMIP 6 runs indicate more pronounced changes both in terms of temperature and also rainfall. What you see is there's a fairly big spread in the results, both in Eastern Africa and also Southern Africa. In Southern Africa, there doesn't seem to be much of a change in rainfall. But that means that we can't just pick one model result here, because that might give us a misleading result. So we need to look at a large enough ensemble to get robust statistics. And if we have a too small number of projections on a local scale, then our results are likely to be misleading due to the law of small numbers, because you might end up picking somewhere around here and miss the whole range here. And also we want to use downscaling because we want to latch on to the model's minimum skillful scale, like the large scale features, what they are skillfully able to reproduce, and also the dependency on those down to the local scale in order to infer what is happening on a local scale as well. And these results are from the GCM eval.met.no. So the capacity building that we are starting with is to develop skills and tools and also share the data. And we want to share the in situ data and compare with the reanalysis, as I said, and filling missing data. When it comes to skills and tools, we are going for R training and climate analysis, statistics and downscaling. And one objective is to use the combination of both the skills but also the tools and data to provide regional information for society and climate adaptation. And also we want to foster a regional network of local experts so they share their experience and help each other to improve. And then finally there's a description of the partners, and they include Mozambique and Malawi and Tanzania and South Africa, and also Kenya and Rwanda and Burundi, and I'm also helping out from Norway. Thank you.